We now move on to the risk section, which serves as the linking element between tasks and costs, both of which we have already explored. In the risks sheet, we find a table that, for the purpose of this course, has been pre-filled with 10 different types of risk. Risks are detailed in column Z. In column B, risks can be included or excluded for marginal analysis. This allows us to evaluate scenarios such as what would happen if I did not include a specific risk, or how would my timeline look if a particular risk were fully mitigated. Now, risks can be classified into two major categories. Activity-associated risks that directly impact specific tasks. They have a two-dimensional impact: frequency, how often the risk occurs, and impact, how it affects both the duration of the associated task and its cost. Examples: risks 1, 2, 7, and 8 that belong to this category. Now, there's cross-cutting risks or transversal risks. These affect the entire project and cannot be linked specifically to a particular task. They do not impact duration as they are not tied to a particular activity. They only impact cost. Now, how we measure the monetary impact using three values found in the following columns. Column P, the minimum value, column Q, the most likely value, and column R, the maximum value. The S column uses either a PERT or a triangular distribution to generate random values based on these parameters. For example, the risk low quality code or insufficient testing has a minimum cost of $500, a most likely cost of $1,000, and a maximum cost of $2,000. The model will generate random numbers within this range in cell S3. Now, we also measure the frequency of the risk, meaning how often it may occur per unit of time. There are three probability distributions we can use to quantify risk frequency. The Bernoulli distribution. For example, the first risk has a 20% probability of occurring. In cell J3, the frequency will be 1 in 20% of the cases and 0 in the remaining 80% of the cases. This type of risk is binary. It either happens or it doesn't. Now, the second one is the binomial distribution. For example, risk number 2, external dependencies and supplier delays, that affects task 14. It assumes that there are 8 external suppliers, each with a 10% probability of experiencing a delay. Cell J4 will show the number of delays, which could range from 0 to 8, with a decreasing probability as the number increases. Now, there's a third distribution function for frequency, the Poisson distribution. For example, risk number 7, technical projects of integration linked to activity number 16, has a lambda, that is an average of 2, associated to a Poisson distribution. It means that on average, the event will happen twice, starting on 0, 1, 2, 3, and so on and so forth. Now, there's impact on duration. For example, risk number 2, external dependencies and supplier delays, occurs with a minimum duration increase of 2 days, a most likely increase of 5 days, and a maximum increase of 8 days. Each occurrence of the risk leads to a delay within this range. In addition to impacting duration, this risk also generates an additional cost. A minimum cost of $400, a most likely cost of $500, and a maximum cost of $1,000. It's important to notice that the cost of this risk is independent of the cost caused by task delays. We must remember that there are uncertainties related to task duration, which should not be confused with risks. For example, task 14 has costs that vary based on the number of days. The number 15, or any other number generated here, represents an updated duration but could have been any other value. This should not be confused with the duration impact caused by risks when they materialize. Now, we need to differentiate between risks in the task sheet. In the task sheet, there is a column that tracks additional risk-related days for activities linked to specific risks. For example, tasks 13, 14, and 16 have associated risks that may increase their duration. These additional days are accounted for in the risk model. On the other hand, the uncertainties in columns H, I, and J reflect other variations in duration that are not tied to a specific risk. So key takeaways. Activity risks cause specific delays when they materialize. General uncertainties cause variations in duration without being linked to a specific risk. Now we can use the risk X sheet that provides additional details about each risk. In cell A2, we can enter the risk number to view detailed information about its nature. This sheet is for informational purposes only and does not affect model calculations. So now we conclude. In this section, we have created an initial risk table, including 1. Risk details, 2. Frequency and probability distributions, 3. Impact on durations and costs. In the next part of the course, we will explore mitigation strategies, analyzing which risks can and should be mitigated and how this affects the risk table.